In this video, we want to talk about a concept known as elasticity. And this is a way of taking the demand and supply chapter, that model of demand and supply that we've talked about, and making it more useful. So up until this point, when you've thought about demand and supply, we've put a demand and supply curve up there, and we've looked at the intersection of that, and we know that intersection tells us the price that's going to end up existing in that market and the quantity of the good that's bought and sold. But we haven't paid any attention to really how we draw the demand curve and the supply curve. And so in this chapter, we're going to be thinking about that. And it's going to be something that we'll use throughout the rest of a Principles of Microeconomics class. It's a microeconomic concept that you use very widely, and we'll talk about how it gets used. But first we need to think about what we're trying to measure and then how to measure it. So we're going to be thinking about a measure that we're going to call the price elasticity of demand. Price elasticity of demand. Now, before we, and I'm going to abbreviate that PED, price elasticity of demand. Before we get into that, let me give you kind of an intuitive explanation for what an elasticity is. So an elasticity really is not necessarily something that economists came up with. It's just a mathematical way of measuring the strength of a relationship between two things that are related to each other. So we can think about elasticities in a scientific context or a physics context or an engineering context, and we can also think about it, of course, in an economics context. But let me give you a couple of examples. So let's suppose that you've got a rubber ball, and you take that ball and you throw it against the wall, and then you measure how far the ball bounces and rolls back once it hits the wall. Now, the force that you use to throw that ball against the wall is going to be related to how far it rolls back. All other things equal, the harder you throw that ball, the more it's going to roll back towards you. It's also going to depend upon whatever the ball is made out of. So if you think about a baseball, if you throw a baseball against the wall, it's going to bounce off and it's going to roll back. But it's going to roll back less than if you had one of those little super balls and you take that and you throw it against the wall and you measure how far it rolls back. For an equal amount of force, the super ball is going to roll back farther. And so there's the relationship between force and distance is going to be different depending on the material that the ball is made out of. We could also think about two things that are related. Let's suppose that you're driving a car and you push on the brake pedal, and then you think about how quickly that car starts to slow down. If you've driven different cars, you know that different cars, a lot of times, the brakes will have a different amount of responsiveness. There are some cars where if you press the brake even a little bit, it starts to brake really quickly, and then other vehicles where you have to press on the pedal really hard to get it to start to slow down. It depends on a lot of things. It depends on the type of braking system. It depends on the age of the brake pads that are on the car. It depends on a lot of different things. But there are two things related there. The amount of pressure that you use to push down on that pedal, and then how quickly the car starts to stop. Now, what we're going to be interested in here is the relationship between the price of a good and how much of it somebody wants to buy. So if we think about a demand curve, we started thinking about a demand curve by looking at a demand schedule. And what a demand schedule is just a list of prices and a list of the number of units that the person wants to buy at each price. And so what we know is that as the price goes up, quantity demanded goes down. But what we're interested in is how much does it go up or down? If price goes up, does quantity demanded fall off a lot, or does it fall off just a little bit? So if you think about a couple of goods that you purchase, we could think about maybe your demand for gasoline. So the price of, let's suppose that when you get done watching this video, you remember that you need to buy some gas, and so you get in your car and you drive down to the gas station. And much to your surprise, you see that the price of gas is twice what you expected. Okay, so you get down there and something's happened, and at every gas station the price of gas has doubled. You're probably going to be disappointed about that because now you've got to pay twice as much for a gallon of gas. And you're probably going to think about how you can use a little bit less gas. You might think to yourself, you know what, I need to take fewer trips to the store. Or maybe when I go to the store, I'm going to buy more groceries so I don't have to drive back to the store in 2 days. But the fact of the matter is, you still need to get to class, and you still need to get to work, and you still need to drive places. And so even though you might use a little bit less gas, you're not going to use a lot less gas. So there you can have a big increase in the price, and your quantity demanded is not going to respond very much. We could think about a different good. We could think about your demand for Pepsi. Let's suppose the price of Pepsi doubles, just the price of Pepsi. Then think about how you're going to respond to that. For a lot of people, if the price of Pepsi doubles, they're just simply going to switch to Coke or switch to some other soft drink. And so there you can have a relatively small increase in price, and people will change their behavior a lot. They will respond a lot to that small increase in price. So the price of gas can change a lot, and people won't respond very much. The price of Pepsi can change a little, and people will respond a lot. There's a different amount of responsiveness for those two goods. And we'll talk here in just a second about what determines how responsive you are, but you probably can already see that the difference between the two examples, gas and Pepsi, is that with the Pepsi example, there is something good to switch to. With the gas example, there's not anything good to switch to. We'll talk about that here in a second. But let me give you a definition for the price elasticity of demand, and we'll talk about some terminology that we use. So the price elasticity of demand measures how quantity demanded, I'm going to abbreviate it that way, how quantity demanded responds to a change in price. So let's think about some terminology that economists use to describe it. We're going to use the term elastic, and we're going to use the term inelastic. So I'm going to use the term elastic when quantity demanded responds a lot to a change in price, and I'm going to use the term inelastic when quantity demanded responds a little bit to a change in price. And I'll define for you here in just a second what I mean by a lot or a little. So you can think about this maybe as a piece of elastic. If it stretches a lot, we would describe it as being elastic. If it doesn't stretch very much, if it just stretches a little, we would describe it as being inelastic. And so hopefully that terminology makes sense to you. But essentially, it measures how willing consumers are to move away from a good when its price goes up. So if the price of gas goes up, how willing are you to move away from consuming that good? If the price of Pepsi goes up, how willing are you to move away from consuming Pepsi? We can think about that in terms of a price decrease. Price elasticity of demand measures how willing consumers are to move towards a good, consume more of a good as its price goes down. But those are that's the terminology that I'm going to use. Let's think about the things that determine how elastic demand is. And there are going to be a handful of these things. Things that determine how elastic demand is. Let's talk about the first one, and I already alluded to that. It's the availability of close substitutes. Availability of close substitutes. So if you think about the gas example, there are substitutes for using gas. If you're going to consume no gas, then there are substitutes for that. Walking is a substitute for not driving. Skateboard, horse. There are a whole bunch of substitutes. They're just not good substitutes. If you need to go any distance at all, then a car is really, really convenient. Okay, so if you're not going to be driving that car, if you're not going to be buying gas, and if you're thinking to yourself, well, I just take public transportation, well, the price of the gas that you're using is just in the price of that ticket that you're going to buy. And so there you're still using gas. If you're not going to use any gas, if you're going to move away from it, there aren't very many good substitutes, no close substitutes. So we would describe your demand for gas as being inelastic. As a matter of fact, let's just put here gasoline as kind of the classic example of a good that has an inelastic demand. On the other hand, if we're thinking about Pepsi, there's a very close substitute for Pepsi. Coke is a very close substitute. For a lot of people, it's almost a perfect substitute. So in that case, if the price of one of them goes up and the other one doesn't, people are very willing to move to that other good. So for demand being elastic, we could say Pepsi or Coke. Those are goods for which there are close substitutes, very close substitutes. So that's the first thing that determines how elastic demand is. The second one is the passage of time. So if we're thinking about how you would respond to, say, a change in the price of gas, let's suppose you go out today and you find that the price of gas has doubled. There are some changes that you can make right now. Maybe you can carpool, maybe you can just take fewer trips. Maybe if you're the kind of person that just likes to drive around and look at the leaves in the fall, maybe you do less of that. But you still need to get to school and you still need to get to work, so you're not going to make huge changes right now. But let's suppose the price of gas stayed high and next month and month after month it was just high. You might start thinking about making other changes. So for example, if you've got a vehicle that doesn't get great gas mileage, you might think about getting rid of that vehicle and buying something that gets better gas mileage. Or you might think about getting rid of your car and buying a motorcycle and being able to consume less gas that way. So over longer time horizons, your demand tends to be more elastic. You tend to respond more when you have more time to respond. Over short time horizons, you tend to not be able to respond very much at all. Okay? So that's something that determines how elastic your demand is. Another thing has to do with whether or not the good is a necessity versus a luxury. Necessity versus a luxury. So a necessary good, I would describe a necessary good as things like food and water. You could describe them, other goods, as being necessary. And for those, they're necessary because there aren't really good substitutes for them. So this one's very similar to the first one. For luxury goods, if we're thinking about an example of a luxury good, that might be something like going to see a movie. So if you think about having some extra income and maybe this weekend comes up and you think about things that you could do, one of them might be to go see a movie. But if all of a sudden the price of going to see a movie went up, there are lots of other things that you can spend your weekend doing. So you and your friends might decide not to go to a movie. Maybe you go to a concert, or maybe you do one of 100 other things that you could be doing on the weekend. So for luxury goods, those tend to be goods for which there are lots of substitutes. And so demand tends to be more elastic for luxuries, less elastic for necessity goods. So that's something that determines how elastic your demand is. We can think about the definition of the market. Definition of the market. So if we were thinking about how we define a market, we could define a market, say, as the market for vegetables. And if you think about what substitutes there are for vegetables, there are some. There are meats and grains and other things that you could be eating. Or we could think about a much more narrow definition of the market, the market for carrots. If we think about how elastic your demand is going to be for that broad definition for vegetables versus your demand for a particular type of vegetable like carrots, there are many more substitutes for carrots than there are for that broad category of vegetables. For the broad category, there are everything that's not a vegetable. It's going to be substitutes for vegetables if you're trying to decide what to eat. If we're thinking about a narrow definition like carrots, there's going to be everything that's not vegetables plus everything that's not a carrot. So there are more substitutes for narrow definitions of the market than there are for broad definitions of the market. So for broad definitions, because there are fewer substitutes, your demand would tend to be less elastic. For narrow definitions, your demand would tend to be more elastic. So how you define the market, that determines how elastic your demand is. And then the last one that we're going to talk about is going to be the share of the good in the consumer's budget. Share of the good in the consumer's budget. So if you think about all of the different goods that you consume, there are some goods that consume a relatively large share of your budget and some goods that consume a relatively small share of your budget. I was in a Principles of Microeconomics class early on in my career, and we were talking about kind of the demand-supply model and how you react to a price. And we were back talking about just why a demand curve slopes downward. And what I had told the class was that there's this inverse relationship between price and quantity demanded. All other things equal, if the price goes up, you want to buy less, and if the price goes down, you want to buy more. And this student raised his hand in the back of the class and he said, "I don't think that's true." And I said, "Well, give me an example, something where you don't think you'd pay attention to the price." And what he said was, "Well, if I were going to go to the grocery store and say buy some gum, I don't pay any attention to the price. If the price goes up or down, I don't pay any attention to that. If I want some gum, I just buy some gum." And he's got a good point. But the point is, he's still paying attention to the price. It's just that the price is so low, he doesn't really care if it goes up or down. So if I asked him, which I did, I said, "Well, what would happen if you were to take that pack of gum and go to the register and all of a sudden it said $10. You would probably," and he said, I wouldn't buy it for $10. And that demonstrates that you're paying attention to price, but you have pretty good information that it's not going to be $10. It's such a small share of the budget, of your budget, that you don't really pay that much attention to it. So the price can go up some, or it could go down some, and you're not going to buy a lot more or a lot less. On the other hand, if we're thinking about goods that have a price that would result in a larger share of your budget, then you're going to pay more attention. So gasoline tends to consume a much larger share of our budget, and we tend to pay more attention to that. So all of these are things that help us understand why some goods have an elastic demand and some goods have an inelastic demand. And again, we'll talk about how to know whether or not demand is elastic or inelastic. What we need to do is clear this off, and then we're going to talk about how to calculate the price elasticity of demand. Let's talk about how to calculate price elasticity of demand. It's going to be a very simple mathematical calculation. If I'm in a face-to-face class and I tell the class that this is going to be a simple mathematical calculation, a lot of people will start to get a little bit nervous and say, "Oh no, I'm not really that good at math, and this scares me." And let me just say, this is going to be very simple. If you can average two numbers together, that's really, in my opinion, the hardest part of this. You'll have to remember a couple of things that are very easy to remember, but calculating elasticity is not hard at all. Let me give you the definition. Price elasticity of demand, it's going to be a number that you're going to calculate. And in the numerator up here, we're going to have the percent change in quantity demanded. Percent change in quantity demanded. In the bottom, in the denominator, we're going to have the percent change in the price. Now I'm going to write this a little bit more concisely. I'm going to use some notation here. Price elasticity of demand. I'm just going to write percent. I'm going to use this Greek delta to indicate change in. We're going to have the percent change in quantity demanded divided by the percent change in P. And that's really it. You're just going to be taking one number and you're going to be dividing it by another number. Let's think about a very simple example of how to do this. So here's an example. Let's suppose that price increases by, say, 10%, and quantity demanded falls by 20%. Price increases by 10%, and quantity demanded falls by 20%. We know there's this inverse relationship, so if price goes up, quantity demanded is going to go down. But let's calculate the price elasticity of demand. So it's just as simple as plugging those two numbers in there. Our percent change in quantity is 20%. You can put that in as 0.2. You can put it in as 20. Doesn't matter. Our percent change in price is 10%. To be technically correct, since quantity is falling by 20%, that should be a negative 20. So let's go ahead and do that. And then you would reduce that. 20 over 10 is just negative 2. That's your price elasticity of demand. So if you've already got the percent changes in quantity and the percent change in price, then it's very simple to calculate these things. It's just one number divided by another number. And we'll talk here in just a second about what exactly that number means, how to interpret that number. But first, let's talk about how to calculate this if you're not given these percent changes. If you have to yourself calculate the percent change, let's think about doing that. Before that, let's talk about this negative sign. So I said, to be technically correct, since quantity demanded is falling by 20%, we need to make that a negative 20. I could have given you this problem, price decreases by 10% and quantity increases by 20%. In that case, the price decrease would be 10% and our denominator would be negative. In either case, the number that you get out is going to be negative. So what economists typically do is we just kind of ignore the negative sign. We know that there's this inverse relationship between price and quantity demanded. One goes up, if price goes up, quantity demanded goes down. Price goes down, quantity demanded goes up. So one or the other is always going to be negative. We know that price elasticity of demand is always negative, and so we just ignore it. If you were to tell me that in this example, the price elasticity of demand was just 2, that would be a right answer because I would know that we're ignoring that negative sign. Let's think about how to calculate percent change. And so if you think about calculating a percent change, let me give you a couple of examples. Let's suppose that you take 2 tests. And on test 1, let's suppose you get an 80. And on test 2, you get, let's say, 100. And suppose I ask you to calculate the percent change in your test score. Let's review how to calculate a percent change. So the percent change, if you're calculating the percent change in anything, you're going to take one number and divide it by another. So we're going to take how much it changed by, the change in test score. Let's write this out first. We're going to take, in the numerator, we're going to have the change in test score. And we're going to divide that by where it started, the first test score, divided by the first test score. Test 1, first test score. We're going to multiply, then you would multiply that by 100 to turn it into a percent. So let's go ahead and do that. I'm going to ignore the 100. You'll see why here in a second. Actually, let's just go ahead and do it. So our percent change in test score here, the test score changed by 20. Our first test score was 80, and then we're going to multiply that by 100. That gives us a 25% increase in your test score. So your test score changed by 20, and 20 is 1/4 of 80. That's a 25% increase. Let's change this now. Let's keep the two test scores, but let's switch the order of them. Let's make test 1, suppose on test 1 you got a 100, and on test 2 you got an 80. And then let's calculate our percent change. So the percent change, this time your test score went down, so it's going to be a decrease, a percent decrease. It's going to be negative, but let's not worry about that. Let's just think about the percent change. It changed by 20. Now your initial test score was 100. We're going to multiply by 100. That gives us a 20% decrease in your test score. So this creates a challenge for us. It creates a challenge because we're using the same two test scores, but it depends on whether we start with the 80 or we start with the 100. If we start with the 80, it's a 25% change in your test score. If we start with the 100, it's a 20% change in your test score. We want to eliminate that problem, and there's a nice simple way to eliminate it, and that is that we're going to use what we're going to call the midpoint method. Instead of dividing by the first test score, we can divide by the average of the two test scores. Okay, so if we think about calculating this percent change with the midpoint method, then here's what we're going to get. If we use the first two test scores, we're going to get our percent change using the midpoint method. It changed by 20. We're going to divide by the average of the two. So we're going to divide by the midpoint of these two. The midpoint and the average are the same thing, and the midpoint is 90, and then we would multiply by 100. So if we used these two and we use the midpoint method, we're going to get this. If we use these two, our percent change is going to be, it changed by 20. The average of the two of these is, again, 90. We multiply by 100. Notice that now we get the exact same number. And we've eliminated this problem of having two different percent changes depending upon the starting point. So this is the way that we're going to calculate our percent changes. We're going to use this midpoint method. So you'll see in the textbook the midpoint method of calculating price elasticity of demand. This is what it refers to. We're going to calculate our percent changes in price and our percent change in quantity using the midpoint method. That way it doesn't matter which price we start with. And that'll make sense, I think, once you see me calculate a couple of these things. So I want to clear this off and then we'll do some examples of this. So let's do a couple of examples of calculating the elasticity, price elasticity of demand using this midpoint method. So we're going to have to, let me put my definition back up here. A price elasticity of demand is equal to the percent change in quantity demanded divided by the percent change in price. Those are the two things that you need, one number divided by another. The way that you're going to calculate both of these percent changes is using that midpoint method. So here's what the percent change in quantity is going to look like. It's going to have in the numerator the change in quantity, so I'm just going to put change in quantity up there. And then in the denominator, it's going to have the average of the two quantities. So I'm just going to put Q average right here. So that's how you calculate your percent change in quantity. You're going to have two quantities. You're going to look at how much the quantity changed, and then you're going to divide by the average of the two. To calculate your percent change in price, we're going to have the change in price up here in the numerator, and then in the denominator, we're going to have the average of the two prices. And that's it. You're going to calculate your percent change in quantity. That's going to give you a number. You're going to calculate your percent change in price. That's going to give you a number. And then you're going to divide one number by the other to get the price elasticity of demand. So let me give you an example. Let's suppose when the price of pizzas, when price of pizzas is equal to $10, let's think about a guy named Bill. Suppose when the price of pizzas is $10, Bill eats 50 per year. Bill eats 50. And let's suppose if the price falls to $8 per pizza, when price is equal to 8, let's suppose Bill eats 70. Bill eats 70. And let's calculate our price elasticity of demand. So we've got two prices and we've got two quantities. Here are the two prices, 10 and 8. Here are the two quantities. We don't care which is the first one because we're going to use that midpoint method. So let's calculate first our percent change in quantity. The percent change in quantity here changes from 50 to 70 or from 70 to 50. It doesn't matter. Remember, we're not worried about the sign of this thing, so you don't even have to worry about that. Quantity changes by 20. And the average of these two, 50 plus 70 is 120 divided by 2 is 60. Or you can just think about the number right in the middle, the midpoint. It's going to be 60. I'm going to reduce that to 1/3. There's our percent change in quantity. Let's do the percent change in price. So our price changed by 2, and the average price is 9. If you add those together, you get 18, divide by 2, you get 9. We can't reduce that anymore. And then let's calculate the price elasticity of demand. So the price elasticity of demand is the percent change in quantity, which is 1/3, divided by the percent change in price, which is 2/9. Now you have to remember that rule of how to reduce a fraction divided by a fraction. A ratio of two ratios. Remember that the rule is you just simply write the top one, 1/3, and you multiply by the reciprocal of the bottom one, which is 9/2. And we can kind of do some reducing here. That gives us a price elasticity of demand of 3/2. And we'll talk about exactly what that number means. Remember, we calculated our price elasticity of demand earlier and it was 2. This one is 1.5, 3/2. So you can see that calculation of the elasticity is not hard. The hardest part, I think, couple of parts that you might think it might be something you haven't done in a little while. You need to remember how to average two numbers. That's easy. And then you need to remember this trick of how to reduce a fraction that's got a fraction in the top and a fraction in the bottom. But once you remember how to do that trick, it's very simple. Let's do another example just to illustrate. So let's suppose, here's another example. When P1, when price is equal to $2, I'm not going to give you even the story with Bill. It doesn't matter. We just need the two prices and two quantities. When price is equal to 2, let's suppose quantity, I'm going to call it Q1, is equal to 13. If price rises to 10, so if price is 10, then our quantity is going to be lower. Let's suppose quantity is equal to 3. Oops, that should be Q1 is equal to 3. That shouldn't be Q1, that should be Q2. There we go. So if price is equal to 2, quantity demanded is equal to 13. And if price is equal to 10, quantity demanded is equal to 3. And I've given these things subscripts 1 and 2, but you don't have to, it doesn't matter which one you treat as the first price. Remember, we're using the midpoint method. So all you need is a price and its quantity. You need two of those, two pairs of price and quantity. So let's start by thinking about our percent change in quantity. The percent change in quantity here changes by 10. And the average of those two is going to be 8. And I can reduce those, I can reduce that fraction by taking a 2 out of the top and a 2 out of the bottom. That gives me 5/4. There's my percent change in quantity. Now I'm going to do my percent change in price. I should put here percent change in quantity. Here's my percent change in price. Price here changed by 8. And my average there is 6. I can again take a 2 out of those, out of the numerator and the denominator. That gives me 4 over 3. So now I've got my percent change in quantity right here. I've got my percent change in price right there. I can calculate the price elasticity of demand. Price elasticity of demand is equal to my percent change in quantity, 5 over 4, divided by my percent change in price, which is 4 over 3. So I'm going to write the numerator, that's equal to 5/4 multiplied by 3/4. That's 15/16. Remember, when you're multiplying two fractions, you don't need any kind of common denominator or anything. You just multiply the two tops and multiply the two bottoms. So now my price elasticity of demand is 15 over 16. A little less than 1. So you can see that the calculation of the price elasticity of demand is not hard. You just need to first calculate your percent change in quantity, calculate your percent change in price. Each one of those is just how much it changed, divide by the average. How much it changed, divide by the average. And then divide one by the other. Any problem that I give you, say on a test or any quiz that you might take, I would give you numbers where you just leave them as fractions, and it's real simple to do this part of it. I will say, though, that we, in my online and face-to-face classes, use an online homework program. And most of the problems on the online homework program, I don't create those problems. I choose from a set of problems. And I can tell you that on the online homework, every online homework problem, they don't give you numbers that are nice and simple like these. A lot of times these will be decimals. So they might have this as 0.333, and that's fine. You obviously need a calculator there. But any problem that I'm going to give you, I'm not going to require that you need a calculator. I would say, if you're comfortable converting these to a decimal, that's fine. I don't recommend that you do that. And in fact, in my face-to-face classes, I require that you just do the fraction stuff here because it's nice and simple. But calculation of the elasticity is easy. One of the things that you're going to see as you read the textbook is that you're going to see a formula. The textbook gives you a formula for calculation of elasticity. And what I've found as I teach this in my face-to-face classes, if I get to this point and I ask the class, does this seem simple to you? Everybody will say yes, it seems simple. You have to remember a couple of things. You've got to remember this definition. You've got to remember how to calculate your percent change in quantity and your percent change in price. But once you remember those, the actual calculations are not hard. When I used to teach this, actually when I learned it, it wasn't taught to me quite like this. It was taught to me a little bit differently. And then when I started teaching, I taught it that way to students. And my experience was that a significant number of my students would have real problems calculating elasticity. I would be grading the tests, and it would just be one student after another. About half the class would miss parts of this stuff, or maybe miss the whole thing. And I always wondered, it always bothered me, because I thought to myself, this is not hard. These calculations are not difficult. I don't know why it is that students have so much trouble doing this. And then one semester I thought, what, maybe it's the way I'm teaching it. Maybe what I need to do is just kind of change what I do. And so I thought, I'm going to try this semester, I'm going to try it this way and just see what happens. And so I did it. And I was a little bit nervous about the outcome. I was grading the test where the students were doing the elasticity problem. And all the students got most of the elasticity questions. I was used to counting all kinds of points wrong on that. Counting all kinds of questions wrong and taking points off. And I was grading test after test, and everybody was getting the elasticity questions right. And I remember thinking, oh gosh, I think somebody's cheated here. I think somebody must have broken into my office and gotten the test. I've never had most of the students get it right. I think there were all but maybe 3 or 4 students got the problems right. And then I thought, well, no, maybe that, I mean, that is a possibility, but I think that's a very slim possibility. Maybe it is that the way I did it this time just made a big difference. So I went back to the class when I gave the test back the next day and I said, hey, how did you guys do the elasticity? And they said, well, what do you mean? It's not even hard. And I said, well, yeah, that's right, but why wasn't it hard? And they said, well, I don't know, it just wasn't. So I think it has to do with the way that you teach this that can make it easier or hard. Let me show you how it was taught to me. So the way I used to teach it, I would go into a classroom, I would talk about what an elasticity is, we'd talk about the rubber ball thing, and I would talk about, you know, the terminology elastic and inelastic, and then we'd talk about what determines whether or not demand is elastic or inelastic, availability of close substitutes, and then we'd say, okay, let's think about how to calculate it, and then I would put a formula up on the board, and here's what that formula would look like. Here's the formula for calculating a price elasticity of demand. Price elasticity of demand looks like this. It's Q1 minus Q2 divided by Q1 plus Q2 over 2. This stuff multiplied by 100 divided by P1 minus P2 divided by P1 plus P2 divided by 2 multiplied by 100. I'd say there's the formula for an elasticity, and now I'd give an example. I'd give an example like this, and then we'd start plugging numbers in, and we'd get the price elasticity of demand. And students would miss it. They would struggle with it. And I think what it is that when you start with this formula, it makes it feel more complicated than it needs to be. When you start with a formula like this, I think it instantly creates a block in students' minds. And there are a lot of students that are convinced they're not good at math, and those students are going to say, oh no, I knew it. I knew that this was going to be something that was hard, and students used to ask me if they were going to get to have a formula sheet, and I would always think to myself, why would you need a formula sheet for this? Because I had done it so long that it made sense to me. And I would say, no, you're not going to get a formula sheet, this is easy, but students didn't believe it. If you think about what's going on here, there are lots of ways to make this simple. What I found is that we don't need to worry about the hundreds. There's one in the numerator and one in the denominator. They're going to cancel out. We just don't even need to think about them. This term right up here, this is just the change in quantity, right? If you write it out, Q1 minus Q2, it somehow feels more complicated than if you just call it the change in quantity. And this term right here, that's just the average of the two quantities. Writing it out like that makes it, again, feel more intimidating for some students, but it's just the average quantity. Let's just call it that. You already know how to calculate an average, so we don't need to complicate it with the formula for an average. This is just the change in price, and this is just the average price. So what I started doing was not writing it out like this, at least not until I had already convinced students that it was easy to do, and then just having them remember this stuff. If you just remember that you're going to calculate your percent change in quantity by looking at how much it changes and then divide by the average, that's easier than trying to remember this. If you're trying to plug things into this formula, that's just hard. It's just too many steps that it's too easy to make a mistake. If you'll just do it like this, it's way easier. So in the textbook, you're going to see this, and if you were to look at videos on YouTube and find other people demonstrating how to calculate elasticity, they're going to show you this formula, and there's nothing wrong with that. If you're the kind of person that likes formulas, this is great, but if you'll just remember it like that, for a lot of students, that makes it a lot easier. So calculation of the elasticity is not hard. It just boils down to remembering this as the most basic thing, and then just calculating the percent change in quantity and the percent change in price using the midpoint method, which has to do with the average in the denominator. So I need to clear this off, and then we'll talk about how to interpret these numbers. What does it mean if price elasticity of demand is 3/2 or 15/16 or 2? So let's clear this off and we'll talk about that. So let's think about how to interpret a price elasticity of demand. It's actually very straightforward. If you calculate the price elasticity of demand, and when you calculate it, the number that you get is greater than 1. So maybe it's 3/2. Or if you're working with decimals, it could be 2 or 2.5. But if it's greater than 1, then we say that demand is elastic. Demand for the good is elastic. If you calculate the price elasticity of demand, and the number that you get is less than 1, and we're going to be thinking about these in terms of absolute values. Remember, it's going to be negative, but we're not worrying about the negative sign here. If you calculate it and that elasticity of demand is less than 1, we would say that demand is inelastic. Oops, demand is inelastic. And if you calculate the price elasticity of demand and it's exactly equal to 1, we would say that demand is unit elastic. So let's think about kind of what the number itself means. Let's think about, let's start by thinking about how to understand these and why these definitions make sense. If the price elasticity of demand, let's just take this first one. If the price elasticity of demand is greater than 1, remember that the price elasticity of demand is the percent change in quantity divided by the percent change in price. That's the definition of the price elasticity of demand. So if that thing is greater than 1, that's telling you that the percent change in quantity is greater than the percent change in price. Our percent change in quantity is greater than the percent change in price. So that's telling us that quantity is changing in percentage terms by more than the price is changing in percentage terms. So people are responding a lot to a change in that price. So we would say that demand is elastic. If the price elasticity of demand, when you calculate it, is less than 1, then that's telling you that the percent change in quantity divided by the percent change in price is less than 1, which tells you that the percent change in quantity is less than the percent change in price. So here, people aren't responding very much. Demand is inelastic. Price could change by, say, 10%, but quantity is only changing by less than 10%, maybe 5% or 4% or 8%. And then obviously, if price elasticity of demand is equal to 1, that's telling us that the percent change in quantity is exactly equal to the percent change in price. So using the definition of this, we can tell that what this number is telling us is whether or not the percent change, whether or not the numerator is bigger than or less than the denominator, whether or not the percent change in quantity is bigger than or less than or equal to the percent change in price. So let's think about how to interpret the actual number. Let's suppose that you calculate the price elasticity of demand and it's equal to 15/16. I think that was one of them that we just calculated. Let's think about how you would describe that. If you went home and you showed your mom these notes on price elasticity of demand and you showed it to her and how to calculate it, and she was impressed and she said to you, okay, but what does the number mean? I understand that the size of the number, whether or not it's bigger than or less than 1, tells me whether demand is elastic or inelastic, but what does that actual number mean? Here's how you would reply. You would say that a 1% change in price causes a 15/16% change in quantity demanded. That's exactly how you would describe it. We always put it in terms of a 1% change in price, just by convention, because it's easier to understand then. So if we had a price elasticity of demand, you calculate it and it turns out to be 2. The way you would describe that is a 1% change in price causes a 2% change in quantity demanded. It's easy to understand in this case because your price elasticity of demand is 2. That's 2 over 1. Here's the percent change in price, and up here's the percent change in quantity. So a 1% change in price causes a 2% change in quantity. Here, we could say it differently. We could say that a 16% change in price causes a 15% change in quantity. But that's hard to understand. So what we've chosen to do is always put it in terms of a 1% change in price. So let's do one more. If we had a price elasticity of demand equal to 4/3, the way that you would say that in terms of a sentence is a 1% change in price causes a 4/3% change in quantity demanded. So that's how we interpret the actual number. What we want to do now is we want to start thinking about what this means in terms of the shape of the demand curve. And then we're going to think about some other elasticities, price elasticity of supply and some other demand elasticities.